And we're live once again. Back in the game. I don't know what I'm saying anymore. But we're back. Today's Thursday, the 21st. This is the last class period before midterms. I'm purposefully slowing my announcements at the beginning just to allow people to get in. So far, it's already jumped to 5. Hopefully, the number will jump up. Oh, it's up to 6. There we go. As people are coming in and getting settled. Next week, you have your midterm. Your midterm will take place on Linkit. Yes, I know. And it will take place on Wednesday, the 27th. Next week, they do the weird midterm schedule 1A, 2A, 1B, 2B, that whole thing. I had a paper over here that I should probably bring over. There it is. It has the midterm schedule. Now, supposedly, this has been mailed home to you guys or something like that, you know? I know. This paper should have been mailed home to you guys, but it has the times and the midterm schedule for this whole thing. It's very strange. So, like, for example, on Wednesday the 27th, you'll be in my classroom from 7:10 to 9:24. Now, assuming that we are going to be in person next week and the rest of you will be virtual. For those that will be virtual, I would be doing a Google Meet instead of the YouTube thing, because why would I do a YouTube video of people just staring at blankness for an hour or two or something like that? So I would be doing the Google Meet. And then for those of you that are here, you'll have your Chromebooks fully charged, hopefully, so that we can do the whole Linkit thing for midterms. Oh, fun. Anyway, but yeah, my goal for today is to finish reviewing for midterms. We started working through a ton of problems last time, and I would like to get done whatever we can today. I have the chat open up on my phone so that I can see things that are happening. As you can see it right there. Inception. It's weird. But yeah. Anyway, I would like to continue working through that. So if you would, on Google Classroom from 2 days ago on the stream, I posted the PDF of the midterm review. So if you do need to see the midterm review, you know what? I'm even going to put that copy of the link to the post. I'm going to throw that into the chat. There we go. So if you needed to see the PDF of the review that we're going to do, please, by all means, do that. Otherwise, if you would, please leave a comment in the chat. That'd be great, just for my records. And we're going to get started. So leave that comment in the chat. I'm going to go meander all the way over here so that we can begin, or continue, I should say, working through the rest of this review. Oh, goodness. Okay. Come on, chat. There we go. My day is going. That's the best that I can say. I've spent now almost 2 weeks in this classroom by myself. There have been multiple days where I have gotten into my classroom and I have barely left it, with like very few exceptions. And I haven't seen, like on Tuesday, for example, I went all of Tuesday without talking to another human being in this building. And that's sad. I don't know. Anyway, let me flip my page over. Oh, goodness. Let's see here. There we go. So again, if you need the review, I put the link of the Google Classroom post with the PDF in the Google Stream or in the chat for the YouTube video, whatever this thing is called. And I would like to continue working through problems. So I'm working on number 4. And yes, for those of you that just joined, please by all means leave those comments in the chat as I see them popping in right now. Please make sure you do that. Working on number 4. Now number 4 gives you the equation 4x squared minus 8x plus 3. And they want you to find the following. They want you to find the value of the discriminant. They want you to determine the number and type of roots. They want you to find the vertex. And they want you to find the exact solutions. We can do that. So the discriminant, for the sake of argument, is that b squared minus 4ac. That is what is supposed to go inside of the square root of the quadratic formula. Be very careful when you are typing this stuff in. As you can see right there, I put parentheses around my -8, because when you square that, it should become positive. So please be very careful when you are typing this stuff in to calculate. If you did this correctly, the discriminant should have a value of 16. Now that tells us so much stuff. If the discriminant were negative, then we would not have any real solutions. If the discriminant were negative, you would have to take the square root of a negative, thus complex solutions. So thankfully, don't have to worry about that. If the discriminant were 0, then you would be taking the square root of 0. It would be like plus or minus 0, which doesn't do anything. If the discriminant were 0, then you would have one real solution. Technically, a repeated solution. But because the discriminant is positive here, it says describe the number and type of roots. You are going to have 2 real solutions. That's just solely based on the value of that discriminant. Then the problem asks for you to find the vertex. Once again, we need to utilize that formula, -b over 2a, and just continue plugging and chugging. -b over 2 times a. Be very careful with how you do this. 8 over 8 gives you a 1. Ah, the glare. Oh, the glare. Let me move that out of the way, the glare. Hopefully. Yeah, a little bit better. Okay. But keep in mind that that is only half of the vertex. In order to find the full vertex, you would have to take that number and plug that junk back in. So I'm going to do that. Let's do that over here. 4 times 1 squared times, or minus 8 times 1 plus 3. Here we go. So it should be 4 minus 8 plus 3. -4 plus 3 is -1, which means the value, or the, the location of the vertex is 1 comma -1. Huzzah! Now, again, all this stuff we kind of reviewed a bit last time. This is kind of more of a warm up for the rest of the review that we're going to be tackling head on. But then part D wants you to find the exact solutions using the quad formula. Okay. Now, I've already done parts of the quad formula, and technically I've done all of the quad formula. I just need to put it all together now. As a reminder, the quad formula, -b plus or minus the square root of that discriminant all over 2a. Now, we've already done the discriminant, which is the square root, or inside the square root, I should say. But then if you cover up, if I use my pen to cover up the value of the discriminant. Move that back a little bit. If I use my pen to cover up the discriminant with that square root, you're left with the vertex, negative b over 2a. So we got to be very careful with how we do this. Negative b plus or minus the square root of the discriminant divided by 2 times a. Again, notice how I wrote that out. This would give me positive 8 plus or minus 4 over 8. Be very careful with how you do the order of operations here. You're going to have to assume parentheses around the top of the fraction, which means you're going to do 8 plus 4 first. 8 plus 4 is 12. 12 divided by 8 should give me the fraction 3 over 2. Or the decimal 1.5. But then I would also have to do 8 minus 4, which would give me 4. 4 divided by 8 would reduce down to 1/2. And that would be sufficient for getting this answer. So let's find the value of the discriminant. Done. Describe the number and type of solutions. Got them. Find the vertex. Well, negative b over 2a, plug it back in to get the y value. Then find the exact solutions. I can do that by just plugging junk in. Oh, this crazy thing. All right. Let's continue to that next page. Again, being that you have the PDF file handy, and again, if you didn't see it, I posted the link to get to the Google Classroom post to see that PDF. But let's continue. Let's see. Chapow. What is the remainder if you divide that crazy polynomial by w plus 3? Now, I'm not going to write out that whole thing because you could see that problem on your PDF of the midterm review. Instead, I'm going to show you what I would do to get that answer. First, I'd create a little synthetic bar. Thankfully, they're in order, w cubed, w squared, w, and then nothing. So 3, 7, negative 4, 3. Those are the coefficients in order from largest exponent to smallest exponent. Then, and this is the part that you got to remember, this is the part that a lot of people tripped up on. On the outside of that synthetic bar, I would put the quote-unquote 0 that I am trying to divide by. Now, I'm trying to divide by w plus 3, but that is not the 0. That is the factor. W plus 3 is the factor. The 0 of that binomial would be negative 3. Now, I have no idea if this is going to work or not. I think that it's not going to work. But that's not the point of the problem. Let's just perform this and see what happens. 3, negative 9, negative 2, positive 6, 2, negative 6, and negative 3. I reminded you a bit of what synthetic division was like last time, where it's just that repeated addition and multiplication, adding things vertically and always multiplying by the number on the outside. Now, clearly we didn't get a 0 at the end, which means it doesn't divide properly, but that is not what the problem asked for. The problem wanted to know what is the remainder. Well, your remainder is negative 3. Oh, happy day. Literally, that's all you have to do for that problem. All right. Let's continue. Number 2, what are the x-intercepts of that equation? Well, you could go about that problem in a few different ways. If you wanted to find the exact x-intercepts, you could just immediately jump to the quadratic formula if you wanted to. Negative b plus or minus square root b squared minus 4ac all over 2a. However, in my opinion, it may be easier to attempt to factor this problem. In fact, I can already see how it would be factorable. Now, just to kind of take you through the basic steps of the Tucker method, the basic steps, reminder of the Tucker method of factoring. Again, if you know a different way of factoring and it works, stick with that way of factoring. Please do. But if you liked the Tucker method, well, the Tucker method started out with taking out a greatest common factor, which in this case, the greatest common factor is 1. So I'm going to, nothing I can do there. I'm going to skip to the next step. Then multiply A times C. A times C in this case gives me negative 15. Then I'd have to find two magic numbers that multiply to negative 15 and add up to that positive 2, which in this case are 5 and negative 3. Now, a T-chart isn't necessary for this particular problem, but I am going to do it anyway. There are my magic numbers in the bottom of the T-chart. It's a 1x squared, so I would break it up 1x and 1x. Nothing simplifies, leaving me with x plus 5, x minus 3. Now, again, those are my factors, not my solutions. Those are my factors, not the roots, not the zeros, not the x-intercepts. To get them, you'd have to set each of them equal to 0 and solve, thus getting an answer of negative 5 and positive 3. Again, know the distinction between factors and zeros. Know the distinction. Okay. The next problem wants you to graph. Now, when we graphed problems like this, we utilized the graphing calculator a lot. Utilizing the graphing calculator is good. You just have to know how to go about it. Now, first, let me just write this function out, but I'm going to write it out slightly different than what the paper says. There we go. I wrote it out slightly different, and the way that I wrote it out differently was, well, it said x minus 2 squared, so I wrote out x minus 2 twice. This function is already factored. And if it's already factored, then you already have the possible zeros or x-intercepts of the graph. In this case, x equals 2, x equals 2, and x equals negative 6 are going to be the x-intercepts of my graph. Now you may ask, oh, Mr. Markey, look, the 2 repeats. Ah, yes, the 2 repeats. There's a repeated 0. Which means, and I believe that this will happen, I believe that when I graph this, there will be a turning point on the value of positive 2. Let's take a look. Go to my graphing calculator here. I'm going to type in the original problem. Get back here, you. X minus 2 parentheses squared, parentheses x plus 6. There we go. Let's graph it. Graph it. Ho-ho. Okay. Now, part of this graph can't be seen, but we need to recognize what the heck is going on here. First of all, you can see the x-intercept. Let me hit trace. You can see the x-intercept at negative 6. There it is blinking right there on your screen. Oh, the glare's in the way. The glare's definitely in the way. But then I can also do it for positive 2. And if you notice at positive 2, there is the turning point. There's a lot of definitions that I can give to this thing, but here's what it comes down to. The degree of this polynomial is 3. It's a third degree polynomial. The way that I know that is based on those x's being multiplied together. If I had to multiply all those x's together, the largest exponent I would get is an x cubed. And because it's an x cubed, an odd degree, and the leading coefficient is positive, the end behavior should look something like that little sketch that I drew. Remember, if it's an odd degree, the end behavior will go in opposite directions. And that's what's happening here, except you can't see it that well. Now, hopefully you can see my mouse here. You can see my mouse a little bit. Now, right here where the mouse is kind of going up, that is the end behavior going towards positive infinity. And down here, that's where it's going to negative infinity. The part that you can't see, in fact, you know what? I'm going to come up and draw this on the board. I don't know exactly how high this thing goes. I'd have to check my table of values here. I don't know how high that thing goes, but that's what it would do technically. It would come back down, and the end behavior would end up being there and there. And this fits all the definitions that we've done for polynomials. The end behavior, well, it's odd, sloping positively because of the leading coefficient. It has at most 3 x-intercepts. And in fact, it technically does have 3 total solutions if you count repeated solutions. And it has, because the degree is 3, it can have at most 2 turning points, which it does. Turning point there on an x-intercept, turning point up there. Now, for the sake of expediency, if you were going to graph something like this, your best bet would be identifying all of that stuff, knowing what this thing is supposed to look like, even though the calculator doesn't show it to you. But then going to your table of values. Second graph will bring you to that table of values. Going back here, you can see right there the -6, 0. But then, man, those other y values are going insane. I wouldn't graph this by hand. I would definitely have a calculator help me do this. Well, yeah. Keep in mind, I mean, if it were a multiple choice on Linkit, you would just have to pick the one that actually does like properly match what this thing is supposed to look like. And perhaps they wouldn't give you something that looked like this. Perhaps they would give you a scaled back version where you would then definitely have to be able to identify end behavior, x-intercepts, turning points, things of that nature. Let's look at number 4. Number 4, what are the solutions to that particular problem? Well, joy, oh joy, oh joy, that particular problem is already factored. It's already factored for you. And because it's already factored for you, you really don't have much to do other than this. Set each term equal to 0 and solve. Here, I get an answer of 0. Here, I get an answer of 3. And here, I get an answer of 1/2. That's all the problem wanted you to do. They already did like half the work for you, which is just weird. Number 5 is ridiculous. I think I mentioned this last class. Number 5 is a ridiculous statement. Number 5, where will a graph of parabola cross the x-axis if it has zeros at 4 and -2? It'll cross it at 4 and -2. Yes, it will. Remember, another word for zeros is x-intercepts. They are exactly the same thing. So you don't have to change anything. I guess this problem is really just identifying your ability to know the terminology, knowing that zeros is the same as x-intercepts, the same as solutions, the same as roots. Whatever. That's weird. Let's go to number 6. composition. If you remember, composition functions are literally taking one equation and shoving it inside of another function. For number 6, they give you f of x equals 5x plus 1, and g of x equals this monstrosity right here. And they want you to perform the function f of g of x. Okay. F of g of x, meaning that g of x is going inside the function. Okay. If g of x is going inside the function, notice the framework that I just outlined right there. The framework of the outside, f of x. It should be performing 5x plus 1, but in this case, I'm doing 5 times that shell plus 1. Well, the g of x is going inside, remember? I would put that 1 over x minus 1 on the inside. Now, could I simplify this? Yeah, I could simplify this. Simplifying this takes you outside the realm of basic algebra 2. Simplifying this puts you back into algebra 1 mode. It's very strange. Let's actually, I'm going to simplify it just for funsies. Should be 5 over x minus 1 plus 1. But in this case, I need to find a common denominator. There we go. It's plus 1, so I did x minus 1 over x minus 1, which is technically plus 1. But now they have common denominators. And since they now have common denominators, now I can combine these things on the top and bottom, or mainly the top, and then the bottom remains the same. I want to be very, very clear about what I just did. What I just did is a skill that we will focus most of our attention on when we get to chapter 8. It's not something that's typically taught in chapter 6. What I just did, finding the common denominator and combining these things together. So don't worry too much about this, what I just covered with my hand. Don't worry about that. Worry about what I did up here. Because the composition function, the act of putting one function inside of the other, that is the skill that you're going to be tested on. Then we come up, it does say simplify your answer completely. But again, I digress. This is a skill that is taught in chapter 8. Number 7. If f of x equals 10x squared, what is 4 times f of x? This is another, wait a minute. Is that what it's asking? Short answer, yes. F of x equals 10x squared. 4 times f of x is 4 times 10x squared, which means 40x squared. I don't know why they decide to put these ridiculous questions next to these simple questions. They go to such far extremes where it's like, hey guys, do this crazy thing that you've never been taught before, and then do this easy thing that seems too good to be true. Yes, I agree. I hate Linkit so much. I really, really hate Linkit. Well, that's the website that we have a contract with. That's part of the reason why we keep using Linkit, because the school has a multi-year contract with the website. I think it would be amazing if I could sign an endorsement deal with something ridiculous like Coca-Cola. and like come in and like wear like a Coca-Cola shirt and teach my lesson with the Coca-Cola logo on me and be like, hey guys, go drink Coca-Cola. Or this lesson's brought to you by Coca-Cola. And then I make like money on the side. That'd be awesome. But alas, we're a part of a union. We can't do that. Number 8. Number 8, inverse of y equals x squared minus 6. Okay. If you happen to remember what we talked about with inverses. Inverses are reflections across the line y equals x. Inverses, well, for every ordered pair in the first function, x comma y, it becomes y comma x in the inverse. Or if you took the composition of two functions and the result was x, then the two functions are inverses of one another. To find the inverse, I outline the steps in your notes where you would have to change like an f of x to a y, but in this case you don't have to because it's already a y. First, you would switch the locations of x and y. That goes along with the ordered pair scenario. The ordered pair scenario of, oh, every ordered pair x comma y is y comma x in the inverse. Yes. Then I would have to solve for y. Okay. X plus 6 equals y squared. I would have to square root both sides. Now, something that actually does pop up when you square root both sides is the fact that you do need a plus or minus when you take a square root. We learned this, or not learned this, but I've reminded you of this back in the quadratic chapter, chapter 4. When you introduce a square root to a problem, you also have to include a plus or minus. That would be the inverse. It's a very strange, wonderful thing. Anywho, let's talk about number 9. Okay, the domain. Let me bring this up here. Number 9. Number 9 wants to know, what is the domain of that graph? Well, keep in mind, domain is the list of all possible inputs. Domain is the how far left and right the graph stretches. What x values are you allowed to plug in? It's a parabola. It's quadratic. It stretches left and right forever. Negative infinity to infinity. That's literally what I would put there. I'd write it like this. The domain is negative infinity to infinity. Now, the range is a different story. Now, the question didn't ask for the range, but if it did, if this problem asked for the range, then it would be the y values. It would be up and down. How far down, how far up? And this thing technically only stretches as far down as -4. So the range would actually be -4 to infinity with a bracket around that -4. It's a weird problem. Number 10. Number 10 is the type of problem that you could utilize a graphing calculator very easily with. Number 10 wants to know, what's the shift? Well, this function, y equals square root of x, its starting point is at 0, 0. Where does it shift? It's going to shift horizontally. It's going to shift vertically based on those numbers, the 3 and the 5. In my opinion, the easiest way to go about it is just to use a graphing calculator, which I'll show you in a moment. But if you didn't have a graphing calculator, you could recognize the fact that we have utilized that function, h and k, in order to identify the horizontal and the vertical shift. The horizontal shift technically is a +3. It's going to shift 3 to the right. And the vertical shift is a +5, which means it's going to shift 5 up. Again, I'm going to put this in the calculator. Square root x minus 3. You got to tab out of that. +5. Make sure that that +5 is on the outside. Graph it. There it is. It shifted 3 to the right. It shifted 5 up. That's literally what you would write down. Okay. Number 11, I'm going to skip over number 11. It says, what are the solutions? We've done 1,000 problems like that already today and yesterday, or 2 days ago, I should say. You could factor it, you could quad formula it, you could do a whole bunch of stuff with number 11. So instead, I'm going to leave number 11 to you to do on your own time. And I am just going to give you what the answers of that problem would be. Spoiler alert, number 11 has no real solution. It has no real solution. The reason for that, I mean, there's a few different reasons for that, but number one, if you graphed it, you would see that it never crosses the x-axis. Then, if you actually calculated the discriminant would give you -20. Yeah, you know what? I'm going to have to write this one out. I mean, like, I'm verbalizing it. I'm like, I'm going to skip it. And then I'm verbalizing it way too much. I'd rather write this one down then. Can't see me? Now you can see me. Okay. 3x squared minus 2x plus 2 equals 0. You can't factor this one, but if you calculated the discriminant, you would get a value of -20. You would get a value of -20. That indicates to me that you are going to get 2 complex solutions. Let me throw this stuff into the quad formula. -b plus or minus the square root of -20 over 2 times a. That would be 4 plus or minus, let me leave that blank for a moment, something over 6. Square root of a negative brings out that I, because the square root of -1 is replaced with the letter I. 20 can be broken up into +4 and +5. So hold up. Square root of -1 times 4 times 5. Let's bring that over. That -1 comes out as an I. That 4 comes out as a 2. 4 plus or minus 2i root 5 over 6. The crazy thing is, this problem can actually be simplified just a tiny bit farther, because 4, 2, and 6 can all be divided by 2. This would give you 2 plus or minus I root 5 over 3 when you simplify everything down. It's a weird problem. I mean, I like it. My intention was just to give you the answer and move on, but no, this problem did deserve a little bit of a deep dive. Whenever you take the square root of a negative. That negative can be removed, but as a result, outside of the radical, it turns into an I. The square root of -1. As a side note, you can also do the square root of -1 in your calculator, as long as you change one of the settings. Square root -1, if you hit enter, you see non-real answer. Oh no, non-real answer. What do I do? Change your mode. You can change it from real to a plus bi. And then when you go to calculate that thing again, it spits out an I. But of course, you have to change your mode. Let me change it back to real. There we go. Excellent. Okay. A small rocket is fired from the ground. It follows that path where h is the height of the rocket in meters and t is the time in seconds. When does the rocket hit the ground? Oh, this problem. I actually do enjoy this problem. When will the rocket hit the ground? Well, there's a couple things you got to know about this. First, the problem is not written in standard form. It's not. But as a result of it not being written in standard form, we actually do have a way of solving this without the quad formula, because we can only use the quad formula in standard form, and without factoring, which we could only do in standard form. Basically, you can solve this for t without having to simplify anything with that parentheses. What I'm going to do is I'm actually just going to use some basic Algebra 1 stuff and use the order of operations backwards. Have you ever noticed order of operations is PEMDAS? That's how you would simplify things down. But if you're going to solve an equation, you got to use SADMEP, which is PEMDAS backwards. This is what I mean. Well, I got to take care of that addition subtraction first. I'm going to subtract the 108. And then I am going to divide by -5. Let me go to my calculator and make sure I get the right number here. There it is. I divide by -5. And I get 21.6 equals t minus 4.7 squared. Now, decimals are going to come into play in a moment. But I'm going to have to square root that sucker. Let me see. Does the square root actually work out nicely for this one? No, it does not. So let me leave it under the square root temporarily. The square root of that equals t minus 4.7. But if you notice, we introduced a square root to the problem. So you got to have a plus or minus out front. And then I'm going to add 4.7. What I just outlined here is actually the most straightforward way of going about the problem. Now, it's not the final answer because I'm still going to have to evaluate that. But I would point out that it looks very similar to the quadratic formula. Very similar. Not a coincidence. You would have to evaluate 4.7 plus the square root of 21.6 and 4.7 minus the square root of 21.6. I'm going to do that over here real quick. Keep in mind that one of those answers is going to work and one of those answers is not going to work. Haha. Excellent. I got two answers. I got an answer of 9.05 and 9.35. It's got to be the 9.35 seconds. There we go. Very similar to the quad formula. It's just handling how you get the solution differently. Okay. Let me skip ahead a little bit for the sake of time. I'm going to jump ahead to number... I can't even read that one. Yeah, I'm going to go ahead to number 17. I can't really read number 17 that well. I wonder if the PDF is going to give me a better view of this thing. PDF. Number 17. Kinda. Not really. I can't really read number 17 that well. Try to open it. Lumen PDF. Bloomin' onion. Come on. You silly thing, you. Okay. Page 3. I'm going to zoom in on that. Oh, okay. I can read it a little bit better. Okay. Just so you know, at the top of the third page, that vertex, I'm going to write it on my paper, should be 4,81.2. That's what it should be. It should be 4,81.2. Okay, that should work out. I'll go back here. Zooming in. There it is. They want to know how long was the ball in the air. Well, clearly it was in the air for 8 seconds. I mean, that's pretty visually, easy. How high did the ball go? That's why I needed the vertex. How high did it go? It went about 81.2, whatever it's measured in. I want to assume feet, but I don't really know. And at what times is the ball 60 feet in the air? Well, it's at 60 feet in the air at the 2 points that I just shaded in. 2 seconds and 6 seconds. Or I assume it's seconds. Because again, this problem didn't even give it to you. Ugh, that's weird. Okay. Number 18, Karen's marathon. Oh, Karen. She ran a marathon in 6 hours. Okay. I couldn't do it. But the question is, between what 2 points is Karen traveling the fastest? Answer: where are the lines the steepest? Where are they the steepest? They even say there may be more than one right answer. Yeah, okay. Keep in mind the scale. Whenever you talk about steepness, you're talking about slope. And if you're talking about slope, you're talking about change of y over change of x. But notice that the y values are going up by 3, and the x values are going up by 1. I could calculate, actually, the slope of every little line segment that you got there. Except for C. I don't really know what the heck C is doing. So let's see. It goes up 6 over 1. So there's a 6 right there. That's not as steep. That's not as steep. This one's going up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1.5. 9 over 1.5 gives you 6 again. That's a 6. E, I don't really know what E is doing. But then it goes up 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it goes up 1, 2, 3, 4, 5, 6, 7.5 over 1.5. 7.5 over 1.5. No, that's a 5. So the correct answers are from A to B and from D to E. Where's it the steepest? Where's it the highest slope? Cool. Is r plus 1 a factor of that function? It's either a yes or a no, and how do you know? If so, what is the corresponding root? Well, if so, first we have to prove it. You prove it with a little synthetic division. Put that over here. Zoom in a bit more. I'm going to put a 4 and a 3 and a negative 10, as we always have. I'm going to put the 0 of the function on the outside as a negative 2. And I'm going to run a synthetic division. 4, 8. No, negative 8. Ooh, negative 8. Negative 5. Positive 10. 0. Yes, it is. And what is the corresponding root? Negative 2. I'm going to bypass number 20 because, again, we've already done a problem like that. What is the remainder? Let me see here. Okay. Number 22. Yeah, number 22. Well, now let's do number 21 first. Number 21 first. I haven't really talked about the concept of axis of symmetry, but it's something that technically you already know how to calculate. It's just that you don't know that you do know. The axis of symmetry of a parabola is nothing more than the x value of the vertex. Let me repeat that statement. The axis of symmetry is nothing more than the x value of the vertex. It's technically a vertical line that cuts right through the middle of the parabola. So if you were to calculate negative b over 2a for that problem, negative of negative 6 over 2 times 1, which is positive 6 over 2, which is 3, there is your axis of symmetry. It's nothing more than that. It's very strange. Number 22. Number 22 wants you to find the polynomial corresponding to this box. This is the box method of multiplication that I've taught you from the beginning of the year, where you just kind of multiply stuff out. That's a 21. But I put a 7 there. 21x, negative 10x, negative 35. And then you combine like terms. 6x squared plus 11x minus 35. And then you all high five each other. Number 23, sketch a function that approaches positive infinity as x approaches positive infinity and has zeros at those numbers. Okay, I'll do it over here. Negative 2, positive 1, positive 3. It's supposed to approach positive infinity as x approaches positive infinity. It doesn't say anything about the left side. So, yeah, there we go. That fits all of the characteristics. That's, yay. That's weird. Number 24. By the way, number 25, I am not a fan of what number 25 is. Number 25 is like, it's so many different things it could be, number 25. It could be a perfect square. It could be a binomial squared. It could be, x squared plus 6x plus 9 if you multiplied them out. You could say it's a quadratic. Like, it's known as a what? Like, you could say so many different things to number 25. But let's focus on number 24. Rate of change. Rate of change is nothing more than slope. Rate of change is slope. If they want to know the slope, okay, well, what's the rate of change? Find the rate of change from 9 to 16. It's like, oh, But what's A and B, and what are they asking me to do? What they're asking you to do is this. First of all, what input makes that function result in a 9? After a little digging with that problem, you could square both sides. You could subtract 8. You could divide by 3. You would actually get 24. 24 times 3 is 72. 72 plus 8 is 81. Square root of 81 is 9. You could do the same thing with 16, which, mind you, I'm bypassing this a little bit because I am running out of time. But you could do the same thing with 16, where you square both sides, subtract the 8, divide by 3. You get a weird number there. Does that number work? Yeah, I'm pretty sure that number works. I want to say it's like 82 2/3. Let me double check that. Sort of there. Let's see. The square root of that plus that. 16, yeah. It's like x equals 82.67. And they want the rate of change, which is really slope. And you got to remember back to your Algebra 1 skills in order to get that thing done, where they really want change of y over change of x, which is really 16 minus 9 over 82.67 minus 24. It's such a weird problem. It's like, why are you even asking that kind of thing here? They want rate of change here. To do that correctly, again, change of y over change of x, I performed the proper calculation. That's a ridiculous number. Why would I even get that number? It's approximately 0.12. I am not a fan of that question. Stupid Linkit throwing these kinds of questions on here. This is what happens when I have to use the same review as everyone else. Don't like it. Anywho, if you did not comment in the chat, I'm going to ask that you do. If you have any questions, please make sure that you are emailing me. I'm hoping to catch up on everything before I leave tomorrow, just because I like to have everything that I need done, including the major that some of you did not get done for me on Edge Elastic. If you did not get that done, you need to get that done. Otherwise, I will not see you again until Wednesday of next week, in which you'll take your midterm. So any questions until then, please make sure you're emailing me so that I can help you out in whatever way I can. I couldn't tell, Joe, if you were saying I did or if you mistyped I died. I couldn't tell. Anywho, the time is 10:28. You are dismissed. And sorry, I'm just busting your chops. And I'm gonna end the stream here. So we'll see you guys next time. Goodbye. 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 You can leave. Bye-bye. Bye-bye. Bye-bye, everyone. Bye-bye, everyone. Bye-bye. I'm just waving bye-bye to everyone with my little crab hand. Goodbye. Okay, bye.